In last session, we had seen how we can design a AWS network with the VPC. And in this video, we are going to again see what is a VPC and what are the services in network services that AWS provides. So let's get started with the AWS network services. So this is our agenda, and let's start. So we had seen in last session, a VPC is your virtual private cloud. It's a fully isolated area where user can place their resources. Resources like EC2 machines, databases, their EBS storages, right? So user can place it isolatedly in the AWS data center. We had discussed earlier as well, because AWS is a public infrastructure, and on a public infrastructure there are multiple peoples who are using the same infrastructure, and they are also placing their resources. So in the among of all the customers, we need some isolated space, and every customer will need some isolated space. And this isolated space is provided by the VPC service, and it's all in the name, a virtual private cloud. That means it's a private cloud for you, but how it is? It's a virtual private cloud. It is not your physical private cloud. It is a logically isolated area. Then user has specific control access on the AWS sources, right? So you can specify the control access on the resources which are placed in the VPC using the AWS policies. You can specify the control access to particular user, like all the resources which are in particular VPC, you have access on that, right? And you can also specify the network access using the firewalls. The firewalls we had seen, a security group and a NACL. So user have control on the VPC level. Then user can manage the services of VPC like internet gateways, route tables, IP address range, that is CIDR, and the subnet in the VPC, right? That makes it a VPC. So whenever there's a VPC must come with an internet gateway, a route table, a IP address range, and a subnet, right? And the other things to notice that is a VPC is a regional service. And the service that we had seen earlier, that was the IAM. The IAM was a global service. It was not a regional service. But in the case of VPC, VPC is a regional service, right? So while creating a VPC, you have to specify the region. In which region you want to create a VPC. It may be Northern Virginia, it may be a Mumbai, it may be a Ohio, it may be a Paris, it may be anything, right? If any case, the region is down, if region is not accessible, your VPC also will not be accessible. VPC will be down, right? So that's why it's a regional based service. It's a region based service. Then there are two types of VPC. One we call it the default VPC, and the other we call it the custom VPC. A default VPC, which by default comes with your AWS account in every region. So in every region, you will get one default VPC that can be used for the people who don't know how to customize the VPC, how to create the VPC, that people can use it. People who don't want to customize. And for your services, like if you want to use some infrastructure, if you want to use some platform services, some software services, so the services can also use a default VPC in backend. The second one is a custom VPC. As per the customer need, as per the project need, you can customize your own VPC. And you can design like how many subnets you will need, what will be the CIDR value, what will be the route tables, the internet gateways. You can design everything over there. That we call as a custom VPC. And in brackets, basically there is a range. So maximum default VPC you can have, it's only one. And the maximum custom VPC that you can have is 5. But that limit is increased, can be increased, right? So the default VPC, it's a hard limit that cannot be increased. But for the custom VPC, this is a soft limit. And this is the soft limit, that means you can increase the limit, right? So maximum customer by default, you can create a 5. That if you have to increase the limit, you can just contact to the AWS. You can send a query for that, or you can just create a case so they can increase your custom VPC limit. Then the other thing that you need to know about the VPC is a CIDR range. That's the classless internal domain routing. That's the range, right? And the preferred range for the CIDR for the VPC is like this: 10.x.x.x, 172.16.x.x, 2172.31.x.x. then 192.168.x.x, right? So why this is a preferred range? This is a preferred range because this is the IP address or standard IP address for the private IPs. If you want to use any other IP address, you can also use that other IP address range, but this is the standard range for the private IP addressing. That's why this is preferred. Then the available CIDR value is from /16 to /28. So maximum you can go to /16 and the minimum you can have is /28, right? And while creating a VPC, you have to select a number between this, right? The subnets. So we are in VPC isolated network, right? And for dividing that network into the subnetworks, we use the subnets. You can divide this network via application basis. Like if you have a database application, it may be in different subnet. If you have web application, it may be in different subnet. If you are in the other application like a DSCP, DNS, then your storage servers, so that all will be in different subnets. Subnet also can be configured via depending on the network connectivity. Like if you are having any public subnet, so that will be connected to the internet. If you are a private subnet, that will not be connected to the internet. So for dividing the VPC into the subnetwork, we use a subnet, right? And the resources cannot be added outside the subnet. It must be inside the subnet. That means if you want to place your resources into the VPC, you must have at least one subnet with you. You cannot add us resources outside the subnet. Then the subnets are the availability zone based, also called as AZ based. The VPC is a region based. So while creating a VPC, you have to select the region, but creating the subnet, you have to select the availability zone, right? Any AZ can have multiple subnets with, but one subnet cannot be split into multiple AZs. This statement is for them who are coming from any like Azure background or GCP background. In GCP or in Microsoft Azure, it's a concept that you can create a subnet into multiple availability zones, but that is not possible into the AWS. You can create a subnet into only one availability zone. A subnet cannot be split into multiple AZs at the same time, right? And then every subnet is private by default. That means whenever you're going to create a subnet, it will not be connected to the route table. It will not be connected to the public internet gateway, right? And it will not have any type of public routes, right? So every subnet is private by default. So that's our subnets. Then a VPC pairing. So whenever company configures the AWS, it doesn't configure the single VPC. They configure the multiple VPCs, and they works on a multi VPC infrastructure. A multiple VPC they can configure like one VPC they are using for production environment, one VPC they are using for testing environment, and one VPC they are using for development environment, right? So they have three different VPCs together. And if they want to communicate from one VPC to other VPC, so for that, they can use a VPC pairing. For connecting two networks together, we use a VPN tunnel in a physical infrastructure. In the same VPN tunnel, you can also use in the AWS VPC connectivity. But the problem is that whenever you connect two VPCs through the VPN tunnel, your whole traffic will go through the internet. Right? It creates a tunnel through the internet and traffic goes to the internet. And whenever your traffic is going through the internet, it can compromise your security as well as can add some extra latency while transferring your data. Right? That's why we use a VPC pairing, because whenever you're using the VPC pairing, your all data transfer through the AWS backbone area network. Right? So for connecting to VPC, you can use a VPC pairing, and VPC pairing can be done between the VPCs which are in same account, or VPCs which are in different account, or VPC which are in different region as well. Right? So in any case, if you have a VPC, you can create a VPC tunnel or VPC pairing. Right? Then the gateways. So the gateways that we have, a gateway we had seen earlier in last video. If you want to go out the network, you will need a gateway. Right? A gateway that can you have is an internet gateway for connecting to the internet. An NAT gateway, if you are in private and still if you want to go to the internet, you will need a NAT gateway. And NAT instances. right? A small difference between the NAT gateway and the NAT instances is like that. A NAT gateway is fully the AWS managed, right? And NAT instances are the user managed. So NAT gateways are called as software services in easy way. And NAT instances you can call as infrastructure services. So in NAT instances, software, your hardware part, network part will be managed by the AWS itself, but the operating system you still have to manage. The patches, updates, the security on the application, all things will be managed by the user itself. With an ad gateway, it's a whole event called a software service. So whole software is provided. You just have to use the software, right? For the NATing purpose, you can go with an ad gateway or the NAT instance. Then you have an ingress only intent gateway. It also has an NAT gateway, but the simple NAT gateway, which is AWS managed, does not support the IPv6. It is just for the IPv4. If you are using the IPv6 in the internal network, in the internal VPC, that time you have to go with the ingress only intent gateway, which is a NAT for the IPv6 network. Then the transit gateway. If you have two gateways or three gateways, you can easily connect them through a VPC pairing. But you have the multiple gateways, like you have 6 or 7 gateways, that time you will need a transit gateway, right? Let me show you in a simple way how basically it works, right? Assume that this is my VPC A, then I have my VPC B, then I have my VPC C. So VPC B and VPC C. If VPC A is connected to VPC B and VPC B is connected to the VPC C, that doesn't mean A directly can connect to BC. A can't directly connect to the C if A is connected to B and B is connected to C, right? This transit pairing is not allowed in the AWS. So what you have to do, you have to create a third connection from A to C, right? It's okay if you have just 3 VPC with you. If you have the multiple VPCs, like say you have the one more VPC and the one more VPC, let's say D, E. So if you want to connect all the VPCs together, so you have to again connect D to E, then D to A, then D to B, D to C. The same thing with the E, E to C, E to D already connected, then E to B and E to A, right? So that will be more complicated if you have more VPCs, multiple VPCs, right? So number of VPC will increase your number of peering connections, right? So in this case, you doesn't have to create a VPC peering connection from one VPC to other VPC. So what you can go for, you can go for the transit gateway. Let's see how it works. So you don't have to create this VPC pairings. Instead of that, just create a transit gateway in middle of it. So assume that this is your transit gateway, a single transit gateway, and connect all the VPCs to the transit gateway. So that will just decrease your number of connections, right? And that will be an easy way to connect all the VPCs, connect multiple VPCs together, right? So this is your transit gateway. So transit gateway can also be a gateway to go out of your network, right? So these are the basic gateways that we can use, like internet gateways, the NAT gateways, ingress gateway, and transit gateway. If you have multiple gateways with you, how would you select which gateway to be used? In last video, we took an example, or like you are in a home, you have 3 doors to go out. One goes to your balcony, one goes to your backyard, one goes to your front yard, right? And whenever we are deciding to select any one of the gate, we select, we first select about the, we search about the destination. We think about the destination. A same thing can be happen with the network as well. And for the network, we use a route table. right? And the route table, you have to add the entries. What is your destination and which gateway to be used for going to a particular destination. And I'll say it controls the routing of subnet. So it is associated, basically, it is associated with the subnet, right? And a same route table can be used for the multiple subnets. But for any subnet, you cannot add a multiple route tables. A subnet can have maximum only one route table, and it must have one route table, right? If you are not associating a route table to the subnet, it will be associated to the default route table by default, right? So every subnet must have at least one route table. It cannot have more than one route table, right? Then a network security. We had seen yesterday as well, we have two applications for the network security. One is a security group, the other is a NACL, that's a network access control list. A security group, it is used on the instance level security, and as NACL work for the subnet level security. A security group is a stateful, and a NACL is a stateless. Security group can manage the inbound rules, right? And the NACL can manage inbound and outbound both rules, right? A security group can only allow, and the NACL can allow as well as block. A same thing that we had seen in last video, right? That's a network ACLs and a security group. VPC Flowlock. As we had discussed earlier, you can assume the firewall or the security group NACL as a watchman of your building. If it is a watchman of your building, a watchman have a logbook, right? And what you put the logbook, who is coming in, at what time he came in, if the person had something with him while coming inside, who is going outside, right? So the watchman is putting all the stuff in the logbook, right? A same logbook we also have for our network that you call as VPC Flowlock, right? So it captures all your traffic which is coming in and which is going in outside, right? And the same traffic can be added to the CloudWatch or to the Amazon S3. Amazon S3 is a storage device where we can store our logs. And CloudWatch is a monitoring tool where we can monitor our logs centrally, right? It's a monitoring tool. Using the same monitoring tool, we can monitor the VPCs using the our EC2 machines, our storage device and all, right? And on the same monitoring tool, you can also monitor the VPC flow log. Then the flow log can be used for the following purpose. It can be used for the diagnosing purpose, it can be used for the monitoring purpose, and it can be used to determine the direction of traffic. If you are trying to connect any of the machine and if it's not going to connect, so you can search in the VPC flow log why it is not going to connect. If you're getting a DDoS attack or DDoS attack on your network, you will definitely get to know the IP address from the VPC flow logs. This is the IP address which are creating attack on the machine. Block the particular IP address using the NACLs, right? So VPC flow log can be used for this type of mechanisms, for the diagnosing, for the monitoring, and for determining the direction of traffic. That a direct connect. It is not a part of VPC, but it is a part of our network services. So the direct connect we use to connect our VPC with a on-premise infrastructure. So if you have the on-premise infrastructure of your company, and if you are using some of the services on AWS, like a hybrid cloud, some services on the on-premise infrastructure and some services on the AWS. So in that case, for connecting your VPC to the on-premise infrastructure, we can use the AWS Direct Connect. So whenever you create a request for the Direct Connect, the AWS provide you a lease line of 1 Gbps or a 2 Gbps through the VPC AWS data center to your on-premise data center. So that can reduce the cost, right? And it will provide you a consistent performance without any latency, right? And this is the basic costing. Like for 1 Gbps, you have to pay $0.30 per hour, and for 10 Gbps, you have to provide you have to give $2.25 per hour, right? So if you want a consistent performance for your hybrid cloud, you can easily go with a direct connect, right? Which provide your connectivity from your AWS data centers to your on-premise infrastructure. right? So in this VPT, we had seen the VPCs, subnets, internet gateways, the route tables, network security, there is your NSCLs and a security group, a VPC pairing for connecting multiple VPCs together, and the direct connect, connecting your VPC to the on-premise infrastructure with a lease line, a physical lease line.